This video will discuss the fundamental theorem of algebra, and which includes writing a function when given zeros. So for this first example, all we're asked to do is to include additional zeros. So in order to know what is expected, you have to understand some of the theorems. So there's a theorem out there that's known as the irrational root theorem, which simply states that if you have a positive root, you're going to also have to have a negative root. There's also a theorem out there that addresses the complex conjugate root theorem or the imaginary root theorem, which is again stating that if you have like a plus bi, you have to also include the conjugate a minus bi. So let's go ahead and get started with this first example. -3 is a real number, so I am good with that. I don't have to find the positive portion of that. It's only when I have a root or when I have an I that I have to add the opposite sign that's not shown. So this final answer here is simply going to be -√5 and 6 plus 7i, because that is the conjugate. Okay, and this one is a positive, so I have to account for the negative. That's it. That's when my directions ask me to include additional zeros. So now if I go to example 2, even though I have a list of zeros shown, my directions are different. This time it asks me to write the simplest polynomial function with zeros. So function, I am going to go ahead and start mine off with f of x, because that indicates I am discussing a function. If it says equation, you could write y equals, okay? What this simply means is I'm working backwards because 0 is representing my x's. So x is -3, -5/2, 0, and negative I. So what I want to do is work backwards. Whenever I move something from one side of the equation to the other, all I do is just change the sign. So I'm going to put all of these zeros in factored form. Well, before I do that, if you ever see a 0 in your list of zeros, and another word for zeros is root, another word is solution, and then another one is x-intercept. So if you ever see a 0 listed in your list here, that simply means x. Because think about it, x equals 0. If I move this over, 0 is neither plus or minus, so it's simply x. Okay, so then I'm going to take the other ones, move them over, change the sign. So now this becomes x plus 3. Now this next one, what you want to do is take your denominator, move it in front of x. So this will be 2x. And then you want to change the sign, and that's going to become your constant. A few minutes ago, I told you that if you have an I or a root, you have to account for both the positive and the negative. So I already see the negative. I'm going to add to my list the positive. So therefore, when I create my factor form, I'm going to do the opposite sign, because again, I'm moving that over to the other side of where x is. So that's going to become x plus I. And then this next one will become x minus I. When you are writing it in factor form, you have to see both signs. One is positive, one is negative. Now, what I am going to do is I'm just going to work 2 at a time. I'm going to take this first x and just distribute it only to that first parentheses. If you did the 2x plus 5 next to the x first, that's okay. It doesn't matter. You'll still end up with the same answer. So this is going to be x squared plus 3x. And then I'm going to go on to my next parentheses. I personally like the box method, so that's what I'm going to use. I have 2x plus 5. And what's going to happen is I'm just going to combine my terms. So I have 2x times x squared, which is going to be 2x cubed, 2x times 3x, which is going to be positive 6x squared. And then I go to my next row, 5 times x squared is positive 5x squared. 5 times 3x is positive 15x. When I combine this, I notice I have 2x squared. So I'm going to combine like terms there. And when it's in standard form, it's going to be 2x cubed plus 11x squared plus 15x. So far I have completed sorry about that. I have multiplied those three. So now let's go to the part that has my eyes to it. So this is really going to be x times x. And then really, I don't even have to do the middle part because since I have a positive I and a negative I, it's just going to go away when I try to combine like terms to become 0. So then I would have visualized this being a 1 here and this being a 1 here because really that's what's going on. What is 1 times negative 1? That's right, it's negative 1. However, I times I is really I squared. And we should know that I squared really means negative 1. So I already have a negative 1. And when I multiply it times the I squared, that simply changes the sign. So this is going to be x squared plus 1. Did you catch that? Hopefully you caught that. So now what I'm going to do is take that information and I'm going to multiply it times the information that I just received. I'm sorry, the answer I just received. So x squared plus 1, because I'm using the box method, I'm just taking this answer and multiplying it times the answer that I already had. So I've accounted for all of my factors, okay? So over here, I have 2x cubed times x squared, which is 2x to the 5th, because you add your exponents when you're multiplying. Okay, and then I have x squared times 11x squared, which is positive 11x to the 4th, and then x squared times 15x, which is positive 15x cubed. I go to my next row and I multiply it times all of everything that's in its column, and I'm going to put the answers here. 1 times anything is itself. So I'm just simply going to write the 2x cubed plus 11x squared plus 15x. So now using my box method technique, I want to see if I have anything that has like terms. The only thing that I see is x cubed and another x cubed. So I can actually combine those. Everything else is going to be as it is. I am writing a function. So it's going to start off with f of x is equal to, in standard form, 2x to the 5th plus 11x to the 4th. I can combine 15 plus 2, which is plus 17x to the 3rd. And then I can put the plus 11x squared and now plus 15x. That is my final answer. So what I want to look for is this, did I actually account for all of my roots? My highest degree tells me how many roots I should have. So let's go back to the beginning. I have 1, 2, 3, 4, 5. So I know that I did account for all of them. If I forgot to put the opposite sign, so if I have a negative, I have to remember to put the positive, then I would have only had 4. So something would have been off. So that's the answer to that one. If I go on to example 3, it's similar. The only difference is now we're going to use the irrational root theorem. So again, I would have to try to figure out what, if any, additional zeros are missing. In this case, I see there is an additional 0 missing because I need to find the conjugate. So -2 minus root 7. So this again simply means x equals 5. X equals -2 plus root 7. And x also equals -2 minus root 7. So working backwards, what I'm going to do is I'm going to put it in factor form. F of x is equal to, when I move that 5 over, it switches signs. Factor form means it's in parentheses. X minus 5 times, now this one might be easier to just go ahead and write it to the side somewhere. Because this is one expression, I'm just going to put it in parentheses. Or since it's all together, that's what I should say. Now, when I move everything over, all of the signs are going to change. So what's really going to happen here is this is going to be x plus 2 minus root 7. That is what's going into my factored form. X plus 2 minus root 7. Now, when I go back and I take the conjugate, I'm going to do the same thing. X is equal to negative 2 minus this time root 7. And when I move it over to the other side, I change signs, x plus 2 plus root 7. That is what's going to go in a set of parentheses, x plus 2 plus root 7. So what you should notice is the first two terms look the same. The only difference is I have a negative root and a positive root. So what I want to do is go back to what I learned years ago, associative property, and it looked something like this. Maybe you had 3 plus parentheses 4 plus 5, and you would do what's in the parentheses first, which is 9, and then you're going to add it to 3. Well, that's 12. Well, what if I wanted to regroup that? I'm still using the same numbers, but this time I want to put the parentheses around the 3 and the 4, and then plus 5. So completing what's in the parentheses first, I have 7 plus 5. Guess what? I still get the same answer, right? That's what we're about to do here. So that x minus 5 that's shown here, I'm going to come back to that. Let me move this out the way. And I'm just going to focus on this portion. So you always do 2 at a time. What I'm going to do is regroup. Instead of keeping the negative 2 plus root 7 together, I'm actually going to regroup and put my x plus 2's together and isolate my radical. So what's going to end up happening, because I'm now multiplying instead of adding, I am just going to take x plus 2 and I'm going to square it. But I have a negative times a positive. So if I have a negative times a positive, I know I'm going to have a subtraction sign. And then I'm going to take that root 7 and I'm again going to square it. All right, so this is really a squared minus b squared for those people that just want to know what's going on. So x plus 2 times x plus 2 is really x squared plus 4x plus 4. That's because 2x plus 2x is going to result in the 4x. And then I taught you a long time ago, if you ever have a radical times itself, it will always equal the radicand. How is that true? What's square root of 7 times square root of 7? Square root of 49, right? What's the square root of 49? Still that 7. So it will always work that way. Now, the only difference is we have to keep up with our sign. So it's going to be a negative sign here. So negative 7. I can combine these like terms. So when I do that, my new answer is going to be x squared plus 4x minus 3. I have to go back to that x minus 5, and I have to include that in my answer. So x minus 5, again, I'm using the box method. You don't have to. And I have x times x squared, which is x cubed. X times 4x is 4x squared. And then x times negative 3 is negative 3x. If I scroll down further, I now have negative 5 times x squared, negative 5x squared, negative 5 times 4x, negative 20x, and then negative 5 times negative 3 is positive 15. I want to see if there's anything I can combine. I do see 2x squareds here. I see an x and an x. And okay, so that seems like that's everything is, I'm combining my like terms here, so I'm good. Again, it asked me to write a polynomial function. So f of x will equal, in standard form, x cubed, negative 5x squared plus 4x squared is negative x squared. Negative 20x plus negative 3x is negative 23x. And then I have a positive 15. This is my final answer. And then my last example is asking you to solve x to the fourth plus 4x cubed minus x squared plus 16x minus 20 equals 0 by finding all the roots. So what you could do is use the rational root theorem, which simply tells you that you're going to take your p, which is your constant, and divide it by q, which is your leading coefficient. In this case, is 1. So I would need all of the factors of my p, plus and minus. So 1 times 20, 2 times 10, 4 times 5. Those are all of my factors of 20. And then all of the factors of 1, which is my leading coefficient. If this had been, I don't know, 10 in the front, if that was a 10x to the fourth, I would have to list all the factors of 10. That would not be fun. Those are all of my possible solutions that I could use for synthetic division to get started finding my roots. So again, it could be plus or minus. I went ahead and I used the Desmos calculator because that's actually a good idea if you aren't given a factor, unless you just want to use the rational root, and that's pretty much like a guess and check type situation. But what I did is I went to Desmos, and you can also use your graphing calculator in class. Just go to y equals and type your polynomial in. What you are looking for is, you don't have to see what the entire graph looks like unless you want to, then you can just adjust the settings over here, the zoom. But what you are looking for is on the x-axis, where does it equal 0 for y? So Desmos is very helpful because you can just click on it and it will give you the points. So it tells me at x is going to be a -5 and x is also going to be 1. But I need 4 answers. This only gives me 2. So I'm going to have to go back and do some work. So that's why I took 1, but I could have used -5 first if I wanted to. But I took 1 and then I went to each one of my coefficients and my constant, and that's what I listed in my synthetic division process. First step is to pull down that first number and then multiply everything below the line times your divisor, which is 1. You do not change the sign if the graph is showing you on x what the point is. That is your x, okay? So now I also saw that -5 was one of my answers. So that's going to be my new divisor, -5. But this time I no longer use these numbers. I used the answers that I just came up with. So I'm going to use 1, 5, 4, and 20. I don't have to worry about the remainder. That just verifies that that is in fact a factor, okay? So I'm going to do the process again. I'm going to pull down the 1, multiply times my divisor, and then combine like terms. So 1 times -5 is -5, 5 minus 5 is 0, 0 times -5 is 0, 4 plus 0 is 4, and then 4 times -5 is -20. I know I'm on the right track if I receive a remainder of 0, okay? So what you are trying to do is keep drilling down until you get 3 terms. Once you get to 3 terms, that is a quadratic. So now I can go ahead and put my variables back in. So I have 1x squared. I don't have a b, so I really don't have to include it unless I plan on using a quadratic formula. And then I go to my constant plus 4. So again, if you're writing this out, x squared plus 0x plus 4, you do not need to write it in that form. You can just skip this part and just go straight to your constant. Now I take that because this is a factor and I set it equal to 0. I am trying to solve for x. And in this instance, I am looking for 2 answers. My highest exponent is a 2. So I am going to subtract 4 on both sides. And I'm left with x squared is equal to -4. I need to get rid of this square because I simply want x. So I take the square root of both sides, but on this side, I'm looking for 2 answers, plus or minus. That will get rid of the square. That was the whole purpose of taking the square root. And I'm left with x is equal to plus or minus. Well, the square root of 4 is 2. And the square root of a negative, this is really square root of -1 times square root of 4. So anytime I have a square root of a negative sign, an I comes out. Square root of 4 is 2. I don't write it as I2. I write it as 2i. I have 2 answers. I have a positive 2i and I have a negative 2i. If I go back to my original problem, my highest amount of roots that I'm looking for is 4. Well, what are they? 1, 2. Those are the ones that people always forget. And then the 2 that I just came up with, 3, 4. So what I would do is just simply create a set, and you don't have to, you can just write x equals and then list them. But I'm going to write a set: 1, -5, +2i, and -2i. Some teachers want you to put them in order. I'm okay with this. All right, so that was how you would do your fundamental theorem of algebra. Have a great day.